In the previous videos, you guys saw how to solve determinant problems using the properties, correct? Now let's see one of the applications of determinants. Now a very simple application, you have already used this last year in coordinate geometry when you calculated the area of a triangle. Okay, now using determinants, we can easily calculate the area of a triangle. Not only that, we also calculated the cross product. Remember how we defined what is a determinant? By using the area of, between the two vectors, correct? Area of a figure between two vectors. So, whenever we talk about vectors, coordinate geometry automatically is included. So, in this case, what we are doing is, you have 3 points and which makes up a triangle, and you are trying to find the area of the triangle. Suppose, let's say you have, so let's assume that we are going to have x and y axis. Here 3 points. Say one point is here, one more point is here, one more point is here. Say this is A, B, say this is C. Now you join AB, join AC, join BC. Now I'm trying to figure out the area of this particular triangle. Okay, the coordinates, say A is x1, y1, B is x2, y2, and C is x3, y3. Fair enough? So we have 3 points, x1, y1, x2, y2, x3, y3. Now the area of the triangle formed by these 3 points. So that is given by area. So delta, you can call it as delta or capital A, whatever, is equal to half into determinant of, you can write in 2 ways. Okay, both of them will give the same answer. So you can write it as 1, 1, 1, x1, x2, x3, y1, y2, y3. This is going to be the area of the triangle. Now determinant can be negative or positive, but area can never be negative, correct? That's why what we take is, whenever you calculate the determinant, even though the determinant can be negative, but we take only the modulus of this particular value. Fair enough? So when you take the determinant, take the modulus of the determinant value, that gives you the area of the triangle formed by these 3 points, A, B and C. Clear? Now, couple of points you guys have to know. Suppose if 3 points are collinear, then it doesn't form a triangle. Correct? So the area of such 3 points will be 0. In other words, you can tell that if 3 points are collinear, then the determinant value is 0, or vice versa. If the 3 points, the determinant of 3 points are 0, then it is collinear. Both, vice versa, we can do. Fair enough? So this is one of the applications of determinants. Now that you know how to find or what is the determinant, now we'll do few problems where you can calculate the area of the triangle, or prove that the 3 points are collinear, or the 3 points are collinear, find the unknown value. Different types of problems are there. Alright, so we'll look into the problems right now. Look at the four problems are there. Okay, so let's solve the first one. See, first one, 3 points are given. You have to figure out the area of the triangle formed by these 3 points. The first one as well as the second one, both of them. So let's start with the first one, very simple. So in the first one, let's say A value is 2, 7, which basically is x1, y1. So this is x1, y1. Next, B value is 1, 1, which is x2, y2. C value is 10, 8, which is x3, y3. Alright, now you all know the formula. So the formula is, you just write down the formula. Formula is what? Delta is equal to half determinant of 1, 1, 1, x1, x2, x3, y1, y2, y3. This is going to be the formula. So this is half 1, 1, 1 2, 1, 10 and then 7, 1, 8. See, you can do the column and row transformation, or you can just directly expand. That's also fine. Okay, any which way. So this is going to become half. I'll just directly expand. 1 into, first 1 into 8 minus 10 into 1, 8 minus 10 minus 1 into, so next it's gonna be 16 minus 70 plus 1 into 2 minus 7, half into minus 2. Next, so minus of minus 16 minus 70, 16 minus 70, correct? Minus 54, then plus of minus 5. So this is going to become half of, see here you are going to have minus 2 plus 54 minus 5, correct? So that's 54 minus 7, you get 47. So final answer is going to become 47 divided by 2. You can keep it like this or you can keep it in decimal. Either which ways, both are correct. So here if you do it, then 47 divided by 2, which is going to give you 23.5 square units. 23.5 square units. This is the answer for the first question. Got it? So for the first one we got 23.5. Let's do the next one. See, for the second one you have, again guys, same logic. So here I'm not gonna do in so much of detail as to what is x1, what is y1. You guys know what it is. I'll just write down ABC. So A value is minus 2 comma minus 3, B is 3 comma 2, C is minus 1 comma minus 8. Now the formula delta is equal to half. See, the same formula can also be written in one more way. I'll show you that one. x1 y1 1, x2 y2 1, x3 y3 1. This is also the same formula. Okay, there is no difference, because when you transpose, do you remember I was talking about transpose? The first property, when you transpose the determinant, value remains the same. That property we can use here. That's why. Okay, anyway, now let's substitute the values. You are going to have delta is equal to half, minus 2 minus 3 1, 3 2 1, minus 1 minus 8 1. This is what you have. Expand. You are going to have half minus 2 into 2 plus 8. Next, plus 3 into, you will have 3 plus 1. Next, plus 1 into, you are going to have minus 24 plus 2. Or this is going to become half into 10 into minus 2 minus 20, 4 into 3 is 12, minus 22. So half into, here see you have 12 minus 20 minus 22, correct? So minus 20 plus 12 is minus 8, minus 8 minus 22 is minus 30. But then again, I told you area can never be negative. So we just take the modulus of it. So final answer, that means area is equal to 15 square units. This is going to be the answer for the second question. Let's do the third one now. See, third one, you have to find the value of k. Area of triangle is 4. Again, determinant. So what we'll do, see, for the third one, let's say a value is k comma 0. Next, b value is 4 comma 0 and c value is 0 comma 2. Okay. Now, delta value is given to be 4. So, 4 is equal to half of determinant 1, 1, 1, K40002. Okay, now here guys, it's very easy for me if I expand it with the help of this and this. Last row, last column. In the sense, I'm talking about taking this, I can expand. So much more easier because the two values are 0 anyway. That's why. So what we'll do now? Cross multiply 8 is equal to 2 into. So when you have 2 into, take off this row, take off the column. 1 into 4 minus k into 1. Isn't it? So you'll have 1 into 4 minus k into 1. So this is going to become 4 times. So what do you get here? You'll get 4 is equal to 4 minus k. That means k value is going to become 0. K value is going to become 0. This is the answer for the first one. In the sense here, you have the value of k to be 0. Clear? Let's do the next one now. See the next one, again the same type of question. So here also, so this is the third one itself, but the second sub question. A value is minus 2, 0. B value is 0, 4. C value is 0, k. Correct? Area delta is equal to 4. So you have 4 is equal to half determinant of minus 2, 1, 1, 1, minus 2, 0, 0, 0, 4, k. Again, you can expand with the second row, first element. Correct? When you're talking about second row, first element, in the sense here, again, cross multiply 8 is equal to second row, first element, right? So, minus 1 into minus 2 into determinant of, because we are taking off this row and this column. So, what do you get? 1 into k minus 4 into k. Correct? 1 into k minus 4 into 1. Correct? So 1 into k is k minus 4. So what do you get here? 4 is equal to k minus 4. So k is equal to 8. K is equal to 8. Fair enough? So this is what we are going to get for the second part. Now we have one last fourth question. Now here you have to show that they are collinear. If they are collinear, then the area of triangle is what? 0. So we need to prove that the determinant value is 0. Then you just prove. See the fourth one, you have to prove determinant is 0. A, B, C they have already given. Just let's write down the formula first. So you have delta is equal to half 1, 1, 1, x1, y1, x1, x2, x3, y1, y2, y3. Let's apply. Delta is equal to half 1, then 1, then 1. You have A, B, C, B plus C, C plus A plus B. Correct? Now you can use different rules of determinants and you can solve this one very, very easy. So first what I'll do, I'll use column transformation. We'll use C1 is equal to C1 minus C2. C2 is equal to C2 minus C3. Fair enough? So if you use this, then the first value half, determinant of 0. Here also you are going to get 0. Here you are going to have 1. This will become A minus B, B minus C, C. Next one, B plus C minus of C plus A, which basically is B minus A. Next, A and A cancels, C minus B, A plus B. Now what do you do? Expand using the first row third element. So this is going to become half into 1 into, See, when you take 1, you remove this row, you remove this column. This into this, minus this into this, correct? Subtraction. So you will have 1 into A minus B into C minus B minus of B minus A into B minus C. Correct? Now it's just expansion of the terms. That's all. Nothing else is there. So when you expand the terms, I'm going to write this expansion of terms here. So I'll just mark a point here. I'll write the expansion of terms here. So you're going to have half into. So multiply AC. See, you can do one more thing. You can just take off the negative sign and also you can do it. But still this way we'll do it. AC minus AB minus BC plus B square minus of B square minus BC minus AB plus AC. See, if you look at this, B square cancels, BC cancels, AB cancels, AC cancels. Pretty much everything cancels out. That means what do we get? We get delta value is equal to 0. When delta is 0, what does it prove? That the 3 points are collinear. Correct? So we just proved that the points A, B and C, what you are seeing in the question, those 3 points are collinear. Clear? See, this is one of the applications of determinants. Fine? In the next video, you are going to learn a new concept of minors and cofactors in the determinant.